man, we got a doozy of a math problem here, children. An absolute math doozy. So we have a square-based pyramid here with EG, my slant height, equaling 16. I've also got angle EGF equaling 60 degrees. Those are my two pieces of information. And we're supposed to find AC, EF, and ED. Three things. A trifecta. A three-course mathematical meal. I'm hungry. Let's eat. Okay, let's see here. So, first off, 60-degree angle and that 16. We have a right triangle. Perhaps I can work with that triangle within the square-based pyramid. Let's copy it out to the other side. All right, so I've got myself a triangle off to the side here. It often helps to take out your triangles from this three-dimensional figure and put them off to the side on a flat space, right? Not that this isn't all a flat space, but you get what I'm saying, right? Two-dimensional drawing. Okay, so I have, wait, hold on a second. We have a 60-degree angle and a 90-degree angle. I think this is a 30-degree angle right here. Ooh, ooh, ooh. I got myself a 30, 60, 90 triangle. They all add up to 180, right? That's how I figured out that 30 degrees. Okay, let's get to work. Across from my 30, if we do recall, across from the 30 is the 1, across from the 60 is a root 3, and across from the right angle is a 2. Okay, so if I know the short side, I can multiply by root 3 to get the 1, or I can multiply by 2 to get that long side. Or do the inverse operation to get back, meaning I would have to divide by 2 to get that short side. 16 divided by 2 is, you guessed it, 8. All right. Now, if I want to get the root 3 side, I would go ahead and multiply by root 3 to get there. So let's draw that in. I would take that 8, I'd multiply by root 3, and now I'm going to have 8 root 3. Bingo, bango. Let's get rid of that. We'll get rid of that. I've just solved that triangle right there. Oh, my goodness. And EF is one of the sides that I want. How convenient. All right, off to the side here, I'm going to put AC. I'm going to put EF, and then ED. We have our three answers that we want, right? EF, we already know, is 8 root 3. Bingo, bango, done. All right, I'm going to shrink this down, and then we'll see if we can find out some other ones. So is there anything we can use from this problem here? Well, I know FG is 8. I can just toss that down there with a marker. And actually, that will be helpful. GF, that's halfway across, right? Because F is at the center of that square base. So all the way across would be 16. In other words, my side lengths, and actually let me do those in yellow. We'll change colors here to get a new problem going. 16 and 16. Now, AC is the diagonal of that base. It runs right through F all the way over to C. So what I could do is we could draw this square flat, all right, and see if we can figure out what that diagonal would end up being. So I have A right here. We have B, C, and D. If I draw in AC, that's what I'm looking for. We'll call that X. And then I've got AD is 16, right? And then I could actually write this as 16 right over here. All four sides will be 16, but I'll make one of my triangle areas with two sides. Okay, so I've got right angles, because it's just square. And then my diagonals of a square bisect the angles. That's a property of a rhombus that carries through to a square. So this is going to be 45, and this is going to be 45 right here. Oh my goodness. I have a 45, 45, 90 triangle. First a 30, 60, 90, and now a 45, 45, 90. You are just too nice, Mr. Allen. You're just too nice giving us all this awesome review. All right, in a 45, 45, 90 triangle, it's 1, root 2. So if I know the short side, whoosh, wow, multiply by root 2 to get there. So what's X going to be? That is going to be 16 root 2. Boom. Dunzo. We've got AC. I love it. I'm going to make that yellow, AC. And yes, sound effects are entirely necessary. 16, root 2 for AC. Awesome sauce. We got one left to go. We already got 2. It's time for dessert in this mathematical 3-course meal. So what now, folks? What now? I'm looking to get ED. I'm going to change this guy to green. We're going to do our work here in green for ED. So this is what's called a lateral edge of our pyramid. But what I'm going to do is I'm going to carry this through. My goodness, did I just find another triangle? And I popped that right angle there because if you remember, the slant height is perpendicular to the base's edge. So we do have a right angle there. I've got one side of that. So let's draw this out. Right triangle, bingo, bango. Now I've got E up here. We have G and we have D. Now I know that this one's 16. EG is 16. Do I know any other lengths here? Because I don't have an angle. Could I have another length? Well, our full side, teacher bracket, is 16. G is at the center of DC, right? It's at the center there, so then it's going to be 8 and 8. So 8 is a length that I can use. Oh, my goodness. I have two sides of a right triangle. Perhaps the only thing missing in this problem is a little Pythagorean theorem. This is not a triple, unfortunately, so we do have to do a little bit more work, but that's okay. We are fully equipped, yes? All right, so I've got 8 squared plus 16 squared equals, we'll call this y now. Since I already used x, I don't want to confuse things. All right, so we got 64, and we've got 256 equals y squared, and then that will give me 320. Okay. Now, we're going to have the square root, and that's not a perfect square. So I'm going to have to factor treat this bad boy. You know what I'm saying? Okay. So we're going to break it down. Now, if you're a fan of perfect squares and dividing by perfect squares, this is a good time to use that. Otherwise, we'll go with the 2 since we usually do that. We'll start with 2s and go from there. I got 160. Then I've got 2 and 80. I've got, let's keep moving. Let's keep moving. I need a little more space. 2 and 40. 2 and 20. 10. And 5. Make sure that looks like a 0. Okay. So we've got ourselves, hold on, children. Look at the date in the bottom right-hand corner. 2/22/2022. I count 6 2s over there, and I count 2, 4, 6 2s right there. So we got 2 times 2 times 2 gives me 8√5. It matches the date. That's dope. That's awesome. How exciting is that? If only it were 222 right now. Maybe I should wait, record this, and try and time it out. Just kidding. I'm not going to do that. So we got 8√5 for our answer there for ED. 8√5. Boom. Woo. Whew. I told you that was a do zero problem. That was dope. That was dope. There were triangles on the face. There was a triangle on the base. There's a triangle inside that pyramid, man. There were triangles all over the place. That was a dope rhyme. All right, hold up. Sorry. Dr. Dre just called, so I got to let you guys go. See you later.